So, lesson 3.4 is essentially, in my opinion, more properties of logs. We did properties of logs yesterday, right? You had those 4 basic properties that helped us when we are simplifying logs. Today we have, I think of it as round 2 of properties of logs. And we have 4 properties here: product rule, quotient rule, power rule, and change of base rule. So, these, I really wish there was a tomorrow, like where I could teach notes again tomorrow, just because these properties that we learned today are really useful when solving equations. Okay, and that's the next step that I don't have time to get to, is solving the equations. But, I know, such disappointment. Product rule. Obviously, product is multiplication, right? So the idea of the product rule is if you have a log, any base, where the inside is a product. So where the inside are pieces multiplied together. That can be rewritten or expanded into 2 separate logs with that same base being added. So the idea of log of r times s is equivalent to saying log of r plus log of s. And that's the product rule. And you can use it either way. Sometimes you need to pull something apart and expand it. Other times you need to put things together and condense it. That's the product rule. If that's a product rule, you can probably kind of guess how the quotient rule works. Quotient rule is if the inside of your log is being divided, that can be rewritten into 2 logs being subtracted. So log of r divided by s is log of r minus log of s. Notice these are all listed as base b. The key is as long as the base matches. We also have a power rule. The power rule helps us with what to do when we have a power. So if you have log of r to the power of c, what you can do is you can take that c, that power, and move it out front as a coefficient. So move it out front to a number that multiplies. So the power rule says, okay, you take this c, and we're going to move it out here. It can be expressed either ways. And again, there's times when you want that c as a power, there's times when you want it as a coefficient. And that's what we're looking at there for power rule. And then the last one, not used so much in equations, but just other miscellaneous things dealing with logs, change of base rule. Okay, change of base rule says that if you have log base b of r, so any base, again, this works for, you can rewrite it as a division problem with 2 logs where it has a base that's on the calculator. In other words, you can rewrite it either as the common log base 10 or the natural log base e, because that's helpful because those are buttons on your calculators, right? If this is log base 7, I can't do log base 7 on my on a basic calculator. It doesn't work. Okay? Our log button is natural log is the e base, regular log is the base 10. And so by having this change of base formula, we can rewrite it. So we can either rewrite it in terms of natural log, so natural log of r divided by natural log of b, or we can rewrite it with common logs, log r divided by log of b. And again, the whole advantage there is that's something that I can use my log buttons on the calculator for. Okay? So those are our properties we are investigating today. Let's look at example 1 and use these properties. The directions on example 1 say expand the following. And the short of it is it's written as 1 log. Let's expand it into separate logs. Okay? So thoughts on the log of 8xy to the 4th of how I can, quote, expand this. What are you thinking?
You could separate each of the x, y to the 4th and 8 out with the
Okay.
product rule.
Okay, so we're going to have how many logs there? Make 3 logs. You guys see that? Okay, it's 8 times x times y to the 4th. So I can expand this, since there's 3 pieces being multiplied in the log, I can expand it to 3 logs being added. So log of 8 plus log of x
Log base 10.
plus log of y to the 4th. And yes, log base 10 because there was no base written in there. So we assume log base 10. I would say I feel like we probably would have done now for 2. So we do I feel like second semester I introduced some basic log stuff. Although this wasn't during quarantine, was it? I know I taught rational functions during quarantine, I remember now, which was the fraction, all the fraction stuff.
Yeah, because I'm gonna forget it.
So, okay, now, what else can I do here? What else, Ashley? Power rule. How can I use the power rule? Yeah. We can also use the power rule, and this is part of just expanding it and simplifying out, and that 4 can move out front. Now, before I do that, before I write my next line out, I want you to pause for a moment and think about log of 8. Because you're not going to see log of 8 in the answer key. They don't like to do that. They like to make you think a little more. What do you know about 8? Huh? You don't have to solve. Nope, we're not picking up the calculators. Okay. Can we agree that 8 is 2 to the 3rd? And so think about this with me. Log of 8 is the same as log of 2 to the 3rd, which means I can then use what property? Power property again. I'm going to move the 4 from the y to the 4th, and I can move the 3 from the 2 to the 3rd. Okay. So, with that in mind, let's write this out. Log of 8 became log of 2 to the 3rd, which now becomes 3 log 2. Plus I have log x plus 4 log y. And at that point, we are fully expanded. We have separated any multiplication or division. We have taken any powers and put them out front. Questions there? Okay. Try the next one. Natural log of the square root of x squared plus 5 all over x. Where would you like to start? Inside the log. What is there and how do we deal with it? Well, don't worry about what's inside yet. Okay, start using the quotient rule, yes? Quotient rule says pieces inside the log that are being divided can be separated into logs that are what? Subtracted. So I'm going to say the natural log of the square root of x squared plus 5 minus the natural log of x. Any other thoughts of what else I could do here? Okay, so a radical is equivalent to having a power of 1/2. And so yes, we can also use the power rule. If you need if you need that intermediate step to see, if I rewrite this, it's natural log of the quantity x squared plus 5 to the 1/2. Notice I did put my x squared plus 5 in parentheses to indicate the whole set was in the radical. So power rule says this 1/2 can move out front. So 1/2 times the natural log of x squared plus 5 minus the natural log of x.
So where do you get the 1/2 from?
It's the square root written as a power.
Oh, yeah.
Okay. Anything else I can do?
There's another power.
Okay, there is another power, but is it on the whole insides of the log?
No.
No. In other words, in order for the power rule to apply, it has to go with everything that's inside the log. So it has to be on that whole quantity. In this case, since it's just on the x squared, I can't do it. It has to be x squared plus 5, with the squared out there. We have addition inside a log. Addition stays. You can't break addition up. It's only multiplication, division that we can break up into other logs. So we are done right there. Notice what example 3 says. Condense. So now they're giving us multiple logs, and we're going backwards. Exactly. We're trying to take all these multiple logs, which all happen to be natural logs, and we're going to put them all together. In other words, our final answer is going to end up being natural log of some quantity.
Yeah.
So what's the first thing I can do?
Well, if 5 can be removed to x, so like x to the 5th.
Okay.
Natural log x to the 5th.
Okay, can we use our power rule here? All of these coefficients can move and become powers. And you need to use your power rule before you try and do a product or a quotient rule. Okay? So the 5 will move and become the power of x. The 2 will move and become the power of xy. And the 3 moves and becomes the power of y. So, natural log of x to the 5th minus natural log of the quantity xy to the 2nd
So it would be a positive 2.
plus natural log of y to the 3rd. Yes, it's a positive 2 because the minus just stays in front of the log. Or at least the way I did it. Let's say it that way. I mean,
It's probably more complicated.
you could. I mean, you could take the negative with the power of 2. This becomes a plus, and then this has to become a denominator.
It would become the quotient.
Exactly. It would work out, but to me, it's easier just leave the signs where they are.
Okay.
That's my teaching choice. Okay? Or it's how I've just seen it done. Okay. Now what? What are your thoughts here? There's a couple different ways we can handle this. So
So we need, since we have both signs.
we do have both
So
signs.
We're going to have a fraction form and we're going to have a form.
Okay. So can you guys see that there's a product and a quotient that's going to happen? Okay, so you've got something that's being added and you've got something that's being subtracted. Me personally, to me, I don't know if this, you guys tell me, is this personal or does this make general better sense? But when I see that minus part, to me it makes better sense in my brain if I put the minus part as the last term and worry about the quotient as the last thing. And so I don't know if that's helpful to just me or if that's helpful to you guys. I'm not saying you'd have to do it. It's not the only way to get the right answer. But a step I might suggest is what's being subtracted here. Switch that and move it to the end. Meaning I could rewrite this as natural log of x to the 5th. And then if I put plus, it's plus natural log of y cubed minus natural log of xy squared. Now, not saying you have to do that. I just find it helpful. Because what do you notice about those first two at this point? Okay. Those first two go together as a product. because two logs being added with the same base could be rewritten as one log with the insides multiplied. So this is going to be the natural log of, yeah, x to the fifth, y to the third. If you want to go ahead and do the division, you can. I'm going to do that in my next step. Notice I put parentheses around my x to the fifth, y to the third. I did that so we know what's in the log for sure. And it's still minus natural log xy squared. Okay. So if you take care of the product rule, we also have to take care of the quotient rule. Two logs being subtracted can be rewritten as one log where the insides are divided. Don't make the mistake of doing natural log of something divided by natural log of something. It's only one log. So I'm going to write it as natural log of x to the fifth, y to the third, divided by, what is xy raised to the second? X squared, y squared? And I guess that my brain's kind of looking a step ahead. You could leave it as xy quantity squared, or there would definitely be an advantage to saying, go ahead and write y squared. Okay? Because if it's condensed and get this as simplified as possible, there's one more step we can take here. And it's more of just an algebra step. It's not log related. Yeah, simplify. Okay? Right. When you have the same variable that's being divided, that means you take the powers and you're going to subtract them. So what is x to the fifth divided by x to the second? So natural log of x to the third. What's y to the third divided by y to the second? Y to the first, or y. Yeah, we've pretty much hit that point up. There's not much else you can do to this. We've got all the x's together. We've got all the y's together. We've got one log. We're pretty much done. Okay, so more than anything, I'm trying to show you what are the pieces you have to watch for today. Okay, that's, more than anything what I'm trying to show you. Questions there? Okay, example 2 uses our one other rule we haven't talked about today. Change of base rule. The change of base rule basically gives us a way to do these problems on our calculator, still using our natural log button and our log button. Okay, so base E and base 10. Evaluate the following using the change of base rule. So evaluate means I want an answer. I want to know what these are equal to. Log base 3 of 16. Can you do log base 3 of 16 on a typical calculator? Okay, it's not going to work with our log buttons, right? Because our log buttons are base E or base 10. So, what does our change of base rule allow us to do? Okay, one option would be log 16 divided by log 3. What base is that? 10. You can rewrite these with any base. If you wanted for some crazy reason say, oh, I want to make them base 5. Okay, defeats the purpose of putting them in a calculator usable form, but you could. Now, Levi had said log 16 divided by log 3. What's the other option here? No. Instead of log base 10, what's the other one my calculator does? Log base E. So in other words, natural log 16 divided by natural log 3. It doesn't matter what you do. When you're solving equations and stuff, you might come down to, oh, do you see other 10s in the problem? Do you see other E's in the problem? But for just what we're doing, finding the value, it doesn't matter. Log of 16 or log of 3? You can't see because I'm zoomed in.
Oh, you need to acknowledge it. Wait,
I don't understand your question.
Like when we have to change the base on the test, or do we just put it in our calculator as log 316? Your calculator will-
No,
I just did.
No.
with a base of 3.
Yes.
Dude, I don't think you're supposed to know how to do that.
Well, I do. That's not kind of stuff.
Okay, so
We left one.
You just clicked down, didn't you?
No.
it's on the menu somewhere.
Yeah. Get there now.
Finally cheating.
Okay,
It's
so.
not cheating though.
No, okay, so here's what I'm going to say. If the directions say evaluate using the change of base rules, then I'm going to expect to see one of these written out. Okay, that's a step I expect to see. Do these fancy dancy TI-84s do any base technically? Yes, they do. Okay,
I mean, I figured they would, and they wouldn't just leave us.
I don't know. I was trying to be subtle. I don't know if anyone caught it, but I would say a basic calculator. The scientific calculators that you guys used last year, can they do any base log? No. If you find it on the TI-84s, do they do it? Yes. Okay, so now what I'm going to say is, as much as that is helpful, there is still importance in also understanding the rule and knowing how to use it, because there are times where it's more about in an equation solving situation or something like that where you need to know how to solve it. Does that make sense? And how to use that rule. So I'm good with you guys knowing both, but understand the rule. Don't just think, oh, well, I have my fancy calculator. I don't have to know the rule. You still need to know the rule. Okay? I know it's in an alpha shortcut menu. Yep. Alpha F2, number 5. That is your other option that I had purposely not pointed out. I knew someone would find it eventually. So, notice all three of those give me the same answer of 2.524. Okay, number 2. So, log base 6 of 10. What are your options of how to convert this? Log 10 over log 6, or natural log 10 over natural log 6. What do you guys get? However you did this on your calculator, what do you get? Sounds like what I'm expecting.
Can't we just also do this like without a calculator?
You can't give me a decimal without the calculator.
Really?
Really?
Because
What do you guys like? I'm about to end.
if it's log base 10,
But we still can't calculate a log without the calculator. There's too much fanciness there for my brain. I'm not calculating logs without a calculator.
To make a calculator, somebody would have to figure out how to do that without.
Oh yeah. Okay. Log base 1/2 of 2. You're either doing log of 2 divided by log of 0.5 or natural log of 2 divided by natural log of 0.5. Or 1/2 if you prefer. What do you guys get here?
yeah, it has to be negative because of 0.5.
Okay, -1. And what it comes down to, if we wanted to get fancy here, log of 1/2 is log of 1/2 would be log of 2 to the
Second, or -1.
negative first,
Yes.
which, if you take that -1 out front, it's -1 times log of 2. And it was log 2 divided by negative 1 log 2, so that's going to be negative 1. Okay, guys. Last thing. And I hate that I had to skip graphs in a previous graph, or in a previous lesson. But I did want to talk about them a little bit here, because it talks about transforming. Okay, so our reflections, our translations, all of that stuff. Describe how to transform f of x equals ln x into the following, and graph the following using the change of base rule. So, this is one of those places where understanding how to use the change of base rule. It's not about how to put it in the calculator, but how the rule works. So, a couple of things to point out. It says describe how to transform. Notice it specifically says f of x equals natural log of x. So even though this problem is a log problem, we want to talk about it in terms of natural logs. And then we're going to graph. So on example 1, it tells me to talk about it in terms of natural log, but it gives me a common log. Well, not even common log, a log base 5. How can I change this so it's talking about natural logs?
You just have to put that log into a natural log.
You give the
Okay, change of base formula. If I rewrite this using a change of base formula, it's what?
Natural log base 5 over e.
No, natural log of x divided by natural log of 5.
There's no e.
The e is understood. You don't write the e in.
Oh.
Just like you don't write a 10 in. Now, the idea is we're talking about transformations. How do we transform f of x equals ln x? Well, that ln x is divided by natural log of 5. But we don't usually talk about dividing by something as a transformation. Dividing is connected to, now, what's dividing the inverse of?
It's just the same as.
Dividing is the inverse of multiplying.
I thought it was going to be like when you make a negative, it's what you're talking about.
Oh, okay. No, that's why you're hooked on the negative subtraction thing. Now, the idea is, if this is natural log of x divided by natural log of 5, this can also be written as, if you pull that natural log of 5 out front, it's in the denominator. And so it could be the idea of 1 over natural log of 5 times natural log of x. Now, what does multiplying a function do in terms of translations or transformations? So if we're looking at,
It stretches, right? Would be a curve.
it either stretches or shrinks. Stretches or compression, stretches or shrinks, whichever words I use in this class. Okay, so when it says how do we transform natural log of x, it's either a vertical stretch or compression, or vertical stretch or shrink. What is it doing? Is it stretching or shrinking? How do we know it's a stretch, if it's a stretch or a shrink?
We can figure out 1. Or no, we know it's going to be less than 1. It's 1 divided by something, so it'll shrink.
Depends what it is. If you're doing 1 divided by a decimal, no. So what is 1 divided by natural log of 5? You guys all have calculators, and you're all staring at me like I'm talking a foreign language. What is 1 divided by natural log of 5?
0.621.
Okay, so if you translate this into 0.621, this is 0.621 times natural log of x. What type of transformation is that? Is that a stretch or a shrink? That we can confirm is a shrink. So my transformation that I'm going to describe is a vertical shrink by a factor, and you could say a factor of 0.621 or a factor of 1 divided by natural log of 5. Now, do you guys remember what I told you one of these graphs looks like? Just a log graph. I heard a whoosh back there of some sort. Okay. A natural log graph goes something like this. Okay? Where it cuts through here at 1, and it goes something like that. What's shrinking this graph going to do? If something shrinks, it's going to be pulled down, right? And so the idea is, if we shrink this, it's going to go closer to the x-axis. And that's what a vertical shrink is going to do there. Okay? If it was a stretch, it would go more above.
But it'll still hit that same spot on the x-axis.
It's still going to hit that same spot on the x-axis. Yeah. Number 2, you end up having to involve a negative, which means there's a reflection along with your shrink. I know that these problems happen in 39 through 42. And I'm just, I'm trying to take a quick peek because I know I'm out of time here. But you can still look at them. I may have to talk about it a little bit more tomorrow, but page 289, 1 through 28, 39 to 42 is what you're looking at for homework. And I will have a review worksheet ready to go for you guys tomorrow.
Yes. For the first